Data storage. If data is stored locally on a device, then searching the local disk memory would provide access to the data. Data can also be stored on external or web-based databases, or on a separate piece of software. If it is sensitive data that should be accessible by the public, like medical records, the data is encrypted. We will discuss in future topics what encrypted data looks like. There is a lot of data in this world that we need to send, receive, modify, and visualize. Storage is one big issue that computers and systems experience because there is so much data to be manipulated. Storing large amounts of data can be made easier by compressing the data. Let's take a look at data compression. Data compression is the process by which a piece of data is encoded in fewer bits than its original file. A file with fewer bits, though, doesn't necessarily mean less information is available. Algorithms have been designed to compress and encode data. We will define encoding in later topics, but the essential understanding of encoding is representing data differently so that others cannot gain access to the original content of the data. Compression works by the algorithm locating repeating patterns in the data and then replacing the patterns with placeholders. As there are algorithms that are used to compress data into smaller file sizes, there are also decompression algorithms that must match up with the corresponding compression algorithms to correctly reconstruct the data. Most devices don't have the computational power to decompress and preview images and videos with large file sizes as quickly as we would want to watch them. Computational power refers to how quickly a computer can perform an operation. Your system's processor and the speed at which it can perform operations will determine the computer's computational power. The greater the computational power, the quicker a system can decompress and stream videos. When a compression method is said to be lossless, no information is lost between the compression of the original file to the decompression or the extraction of the compressed file. Ideally, you'd want most of your compression to be lossless so that pictures aren't distorted and the quality of a video is as high as it can be, but oftentimes data compression can cause files to lose some information or quality. Most software has its own algorithms that determine how small to compress data based on what the software needs to do with the data. When reconstructing identical data is the most important factor to data compression, lossless compression is used. Run-length encoding is a method of encoding text that has many repeated characters. It is considered to be a lossless compression format, as the original file can be identically reconstructed after being compressed. This method of lossless compression works by specifying the number of times a character or pixel repeats, followed by the value of the character or pixel. Run-length compression is the most efficient compression method when there are many repetitive pieces of data. Consider the message below. There are 12 characters, each represented by 8 bits, or 1 byte. This message is originally 12 bytes. If we use run-length encoding, we need to identify how many of the first character are written consecutively, and then list the name of the character. The encoded compression is 4B, because there are 4 B's, 4C, because there are then 4 C's, 3E, because there are 3 E's, and 1F because there's 1F. With this encoded compression, the message is now 8 bytes long, making it smaller in size than the original message. A lossy compression algorithm compresses file sizes to be much smaller than those compressed using a lossless algorithm. This means that the original piece of data cannot be identically reconstructed after it has been compressed. Lossy compression algorithms will actually allow you to change how much precision is lost during the compression. This allows for a smaller or larger compressed file based on the user's choice. Although a lossy compression algorithm will be able to reconstruct the data once it is decompressed, it will only be an approximation of the original data, as some bits were lost permanently. When shrinking data size is the most important factor to data compression, lossy compression is used. Bitmap and portable network graphics image formats are two common examples of lossless compression. Joint Photographic Experts Group, or JPEG, image format is a common example of lossy compression. Can you tell the difference between the two? Most of the differences between lossy and lossless picture compression formats are not easily visible to the human eye. Consider how much storage your cell phone has. Imagine that you want to save a long video on your phone. However, your phone is not capable of storing a video 300 gigabytes in size. A few benefits of data compression are that data compression saves storage space, enables a faster transmission of data since the data is smaller, and storing compressed data is less expensive since less storage space is needed.